All right, so we're going to do some more word problems in this video. Some of them are going to have answers that are polynomials, and some of them will actually be able to do beginning to end. So the first one we're going to start with is this question about Janine and her wedding planning. So she's using a water-based centerpiece. She's got 30 tables. I need to keep this in mind because that's going to come back into play later. She has cylindrical vases for her tables. The radius of each of the vases is 6 and the height is 28, and both of those are in centimeters. She's going to fill them halfway with water and then add marbles, so the water line is about 3/4 of the way up the cylinder. So that tells me that 1/4 of the volume is going to be marbles. Half water, bumping it up to 3/4 means 1/4 of that has to be marbles. Bags are going to have 100 marbles in each. They're going to be 9 millimeters or 12 millimeters. Cost is going to be $3 for the small marbles and $4 for the large marbles. So our goal is to figure out how much she would spend if she only bought 9 millimeter and how much she would spend if she only bought 12. So in order for us to do that, we first have to figure out the volume of marbles that we're going to be using for our total of all 30 vases. So the first thing I have to do, let me zoom out a little bit. First thing I have to do is find the volume of the vase, and I'm just going to do one vase in general. So since it's a cylinder, I'm going to use pi r squared times height. So that would be pi times 6 squared times 28. And I just put this straight into my calculator, and that is about 3,166.725 cubic centimeters. And since only 1/4 of that is going to be marbles, I need to divide that 3,166.725. Need to cut that down to only 1/4, so I'm going to divide that by 4. So that tells me give myself some more room. My marble volume for one vase is going to be 791.681 centimeters cubed. So this is the marbles in one vase, the volume of the marbles in one vase. And we need to know that that's for one vase because that's going to be important later on. Okay, so this is the total amount of volume I have to cover of marbles in each vase. Well, now I need to figure out the volume of each single marble so that I can figure out how many marbles I need in each vase to make this much volume for marbles. So this is all in centimeters. I need to convert the millimeters into centimeters first. So 9 millimeters, I'm going to divide by 10. So that would be 0.9 centimeters. And since this is a ball or a sphere, I'm going to use the sphere volume formula, which is 4/3 pi r cubed. Which is about 3.054 cubic centimeters for my 9 millimeter marble. I'm going to do the same thing with 12 millimeters. Going to turn it into centimeters and then use my sphere formula. Which gives me about 7.238 cubic centimeters. So this is the volume of one 9mm marble. And this is the volume of one 12mm marble. So that's another thing I need to remember. And then now I'm going to deal with the money part of this. So this is my total volume I need to cover. This is the volume of one 9mm marble. So if I divide those, that tells me I need 259 marbles to make one vase this full of marbles. Now that's only one vase. I need to do 30 vases. So I need to take 259 and multiply it by 30, and that will be for all 30 vases, which is 7,770 marbles. And in order to figure out how many bags I need to divide that by 100, because there's 100 marbles in every bag. So that would be 77.7 bags. Well, I can't buy 7/10 of a bag of marbles, so that needs to be 78 bags total. So I need 78 bags of my 9mm marbles in order to make this much volume for each of my 30 vases. And then doing 78 times 3 tells me that I would spend $234 filling up these vases with 9mm marbles. And I'm going to do the same thing with 12mm. So I'm going to take my total volume, which was 791.681, and divide it by my volume of one marble, which gives me 109 marbles. And then I need to figure out how many I'm going to need for all of my 30 vases, which is 3,270 marbles. Dividing by 100 would be 32.7. So I need to round that up to 33 bags because I have to buy a whole number of bags. And then these are each $4. So 33 times $4 is going to be $132 total. So a lot of work just to figure out how much money we're going to spend based on these marbles. Now the next one, we're going to write a system of equations to figure out how much money we would be spending if we're going to do a combination of these. So the first thing I'm going to do is I'm going to do X and Y, and I'm going to determine what I'm going to have them represent. So I'm going to have this represent the number of 9mm bags for X, and Y is going to be the number of 12mm bags. And I'm going to write two different inequalities or equations. The first one, I'm going to do a cost inequality. So we want to spend at most D dollars. Oh, and it froze. Isn't that lovely? There it is. So I have $3 times the number of 9mm bags I buy, plus $4 times the number of 12mm bags we buy. And that has to be less than or equal to however much money we're going to spend. So that's my cost inequality. Now I also need to do this with volume because the cost and the volume, I have to find where both of those constraints are met. So ultimately, I'm going to have to graph this system of inequalities or equations. So for volume, I need to take the 100 marbles that are in each bag, and I need to multiply that by the volume of my small marbles, which is 3 point, where did it go? 0.054. And then I need to multiply that by however many bags I'm going to buy. So this is how many marbles are in each bag. This is the volume of one of my small marbles, and this is the number of bags that I'm buying of my small marbles. And I'm going to do the exact same thing with my 12 millimeter bags. So I'm going to have 100 marbles in each bag. I'm going to multiply that by the volume of one of my one of my large marbles, which is 7.238. And then I'm going to multiply that by however many bags of those marbles I'm buying, which in this case I'm just using Y. And that has to be 791.681, which is one vase. And then I need to multiply this by 30 because I have 30 vases altogether. So this is for all the vases. Now I can simplify this before I graph it. And I'm going to actually put my system over here to the side. So I'm going to have 3x plus 4y is less than or equal to d. And then I'm going to actually just multiply these things together, and that's how I'm simplifying my second equation. So this is going to be 305.4x plus 723.8y being equal to, and of course I'm running out of room, 23,750.43. So this is my system, which got a little wonky, but you know what I'm doing. All right, so I'm going to use this to figure out if she has $180, what she could buy of each marble. So I'm going to go into Desmos, and I'm going to do two different equations. The first equation is going to be my cost equation. So 3x plus 4y, not 4d, 4y, being equal to the amount of money I want to spend. And then my volume equation, 305.4x plus 723.8y being 23,750.43. So I go into Desmos, and I'm going to graph both of these things. I don't know if I have Desmos open already. I don't. So opening up Desmos, we have 3x plus 4y equals 180. And then 305.4x plus 723.8y being equal to 23,750.43. I'm going to zoom out forever until I see my intersection. So remember, X is the number of 9 millimeter bags and Y is the number of 12 millimeter bags. So my X value tells me I can buy 37 bags of the 9 millimeter marbles. And Y tells me I can buy 17 bags of the 12 millimeter marbles. So coming back over here, this would be my answer if she only wants to spend $180 total. So the next one we're going to look at, we have a polynomial expression that represents the volume of the cube. So I'm doing length times width times height. So I have 5x minus 2 times 5x minus 2 times 5x minus 2. Now you can do the box method in this case, or you can do double distribution with 2 of these and then distribute with the third one. I'm going to do double distribution the first time, and then the second time I'll do the box method just so you can see both options. So the first thing I'm going to do is just choose 2 of these 5x plus 2's. So 5x times 5x gives me 25x squared. 5x times negative 2 gives me negative 10x. Another negative 10x, and then a plus 4. So that's going to be 25x squared minus 20x plus 4. And then I'm going to multiply this by 5x minus 2. And I'm going to do this one using the box method instead of double distribution. And now we're just going to go through and multiply. So 5 25s gives me 125. X squared times x gives me x cubed. 20 times 5 would be 100, so negative 20 times 5 would be negative 100. It's going to be x squared because they both had an x. And then this is going to be positive 20x. 25 times negative 2 gives me negative 50x squared. My next one would be positive 40x, and then minus 8. So my polynomial expression that represents the volume of this cube would be 125x cubed minus 150x squared plus 60x minus 8. We're going to do something similar here, except I'm doing a cylinder. So I need to use pi r squared h. So the first thing I need to do is square my radius. So r squared is going to be 2x plus 1, the quantity squared, which remember means I'm doing 2x plus 1 times 2x plus 1. So 2x times 2x gives me 4x squared. 2x times 1 gives me 2x. Same thing again. And then plus 1. So r squared is going to be 4x squared plus 4x plus 1. And then if I need to do r squared times h, I need to do this, 4x squared plus 4x plus 1 multiplied by 6x. Since this is a monomial, I just need to multiply each of these terms by 6x. So 6 times 4 is going to give me 24. X squared times x gives me x cubed. Then I'll have 24x squared and then plus 6x. And then at the end of this, everything has to get multiplied by pi. So this is one way you could see it. You could also see it where pi is distributed into each term. And if that was the case, and this was a multiple choice question, pi is going to be attached to the coefficient because pi is a number. So I would have 24 pi x cubed plus 24 pi x squared plus 6 pi x. So this is what it would look like if pi was distributed. This is what it would look like if they did not distribute pi into your answer. All right, so we're creating a box that has a volume of 30 cubic inches. So I'm going to go ahead and start drawing myself a picture. So the width should be 2 inches less than the height, and the length should be 5 inches greater than the height. So I'm going to make the height x. Whew, my drawing skills are rough today. So the height's going to be x. The width should be 2 inches less than the height. So this should be x minus 2. And the length should be 5 inches greater than the height. So I'm going to write myself a volume equation. So I have 30 being equal to x times x minus 2 times x plus 5. And because we have access to Desmos, we're going to come over here. I'm going to get rid of these ones I had before. And I'm going to type it in exactly as I saw it. X times x minus 2 times x plus 5. Oops, sorry. Should be y. And then I'm going to do my second one as y equals 30 because I want my volume to be 30. So in this case, y is our volume. So I'm going to come in here. I see an intersection down here, but since x is our height, it doesn't make sense for our height to be negative. So I'm going to choose the positive intersection. So our height is going to be 3.16 inches. I'm going to come back to my screen here. So our height is 3.16 inches, which makes our width 2 less than that. So 3.16 minus 2 gives me 1.16 inches. And our length would be this plus 5, so 8.16 inches. And last but not least, another rectangular prism. So this is another length times width times height. So this would be 3 times 2x minus 1 times 2x plus 3. Personally, I would choose to do this first because it's a lot less work when I have to go do that second multiplication. And I ran out of lead. All right, so 3 distributed into 2x minus 1 gives me 6x minus 3, which then I'm going to distribute with, helps if you write down the right numbers, 2x plus 3. Again, you can do box method or double distribution. Totally doesn't matter. I'm going to just double distribute. So 6x times 2x gives me 12x squared. 6 times 3 gives me positive 18x. Negative 3 times 2x gives me negative 6x. And then at the end, we're going to have negative 9. Combining these two like terms gives me 12x squared plus 12x minus 9.